All right, so in this lesson, we are going to prove congruence of two shapes using rigid transformations. So basically, if we can reflect, translate, or rotate from one shape to the other, then we can say for sure that they are congruent, like that they are the same size. Basically the same size, same shape, same property. So let's prove, before we do that though, before we prove congruence using reflections, translations, and rotations, let's review some reflections real quick. So we can tell that this shape was flipped. Oh, the other way around. This one was flipped to become that shape. This is the pre-image. And then this was the image. We can tell it was flipped over this line right here. So this is the line where x is always 2. So it was reflected over the line x equals 2. The x-axis is here. The x was always 2. Let's look at this example number 2. It doesn't really tell us, but let's go this way. We'll just say that this is the pre. So we can tell that this was flipped over, let's see, not here, right here. Okay. We can tell that this flipped over this because they're both the same amount of units away. So the pre-image was reflected over the line. This is where x is always 9. Over the line x equals 9. Example number 3. So this looks like these are primes. So it went like this. And it looks like it was flipped over this line. So once again, it was reflected over x equals -2. I actually meant to put a vertical sort of flip, but it's all right. So you can tell in this one, this is one of the vertical flips that I'm talking about, one of the vertical reflections. So 1, 2, 3, 4, 5, 6, 1, 2, 3. So this one's actually reflected over this line instead. Like vertically, it's reflected. That is not where x equals 3. That is our y-axis. So it's where our y always, it's reflected over the line y equals 3. How do I reflect it over y equals 3? Remember, this was where the x was always -2. And this is where the y is always 3. So let's start proving some congruence. So it says a triangle ABC is congruent to DEF. Draw a picture depicting the relationship and label which angles and side lengths are congruent. Okay, so there's a lot there. So let's make two congruent triangles, ABC, A, B, we'll do it like this, A, B, C. Now we're going to try our hardest to make sure that this next shape, DEF, is congruent. So I'm going to try to draw the exact same size. So D, E, F. And I'm going to make this one a right triangle also. So, I mean, they're trying to be congruent, okay? It's the best I could do right now. So it says draw a picture depicting the relationship. So we did. So we can they're congruent. And label which angles and side lengths are congruent. So AB is congruent to, I'm going to write that a little smaller. That's not where you meant. I think it's just because it's so thick. Okay, is congruent. So A to B is congruent from D as D to E. I want to put E and then D. Put it in the same order. D, E. AC is congruent to DF. BC is congruent to EF. And actually, this should have these two lines. If not, it just means similar. But they're not. They're congruent. We're not talking about similar. And it also asks about the angles. So angle, instead of saying angle BAC or something, we're just going to go angle A. Okay. So angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Cool. So it says prove the two shapes. So they're kind of hard to see. So I'll outline them a little better. That's one of them. Not perfect, but better than what it was. Okay, so prove that these two shapes are congruent by identifying the rigid transformation you can use to get from A to B. So we're going from A to B. I know that's kind of far away, but yeah, we'll say this is A. This is B. So remember, we can either translate, we can reflect, or we can rotate. It looks like it was just slid, so we're not reflecting, we're not flipping it, we're not like rotating it around something, we just moved it. So I translated this 1, 2, 3, 4, 5 to the left, and then 5 to the left, and then 1, 2, 3 down, so -3. And I can check that again with any one of these. So 1, 2, 3, 4, 5, 1, 2, 3. Yeah, I translated left 5 and then down 3. I can probably make that box a little, we'll help it make a little more sense. Okay, so it says once again, we're going to prove that these two shapes are congruent by using a translation, a rotation, or a reflection. We can tell that, well, I guess we're going from A to B. Yeah, A to B. So it looks like it was just flipped over. It was like flipped over this line right here. So it wasn't translated, it wasn't rotated, it was flipped. So it was reflected. So it reflected over, that is the x-axis, 0, 1, 2, 3. So it was reflected over the line x equals 3. Cool. Next page.